So looking at this assignment, there are a lot of problems, and it's sort of just the same thing over and over and over. So I've decided to do every other odd, which would mean 1, skip 3, do 5, skip 7, do 9. Does that make sense? Now, the law of cosines is something we talked about last year. So there are actually 3 different versions of the law of cosines. And if you memorize one of them, then figuring out the others is actually really easy. So turn to page 490. Hold on, I'm not there. Okay, 492. So you see 3 versions of the law of cosines, and I'm actually going to start with the last one. So the law of cosines says c squared is equal to a squared plus b squared plus or minus 2ab cosine of c. Now they don't use c, they use, I think that's gamma. Yeah. So I'm going to write it out like that. Now, I derived this formula for you last year. I don't need to do it again. This formula looks really similar to something that I already know. It looks like the Pythagorean theorem. So let's draw a right triangle and see what's going on. So here's my right triangle, A, B, C, which would be C, B, and A. Okay? So I know that this is a right angle. So if this is 90 degrees, what is the cosine of 90 degrees? So cosine is the length of the ground. We rotate 90 degrees. The length of the ground is 0 at 90. So when C is 90 degrees, this turns into 0, which means all of this also turns into 0, and you're left with the Pythagorean theorem. And the Pythagorean theorem only works if C is 90 degrees. So the Pythagorean theorem is actually just the law of cosines when your angle is 90 degrees. Yeah, well, we'll talk about that in just a second. If this angle becomes slightly larger than 90 degrees, then these things over here don't go away. And we get c squared equals a squared plus b squared minus 2ab cosine c. And the cosine of c is no longer 0. So the Pythagorean theorem is actually just the law of cosines when your angle is 90 degrees. Okay? Well, there are different versions of this. You don't have to start with c squared. You could actually start with a squared. So that would be b squared plus c squared minus 2bc times the cosine of a. Does that make sense? So basically you start Pythagorean theorem. This letter goes there, this letter goes there, and then that letter turns into an angle. Okay, that is the law of cosines. And what would the other one be? B squared equals a squared plus c squared minus 2ac times the cosine of b. All right. When we did the law of sines, which 3-value combination could I solve for in law of sines? I couldn't do side angle side. I could do angle side side, angle angle side, and angle side angle. So when I did the law of sines, AAS worked, A SA worked, and then angle side side worked, but it was kind of problematic. We ended up with 1, 2, or no triangles, depending on the situation. Okay? Well, these do not work for the law of cosines. Any guess on which two do work? Side angle side and side side side, which is good because that takes care of all of them. Right? Those are all of the triangle angle side relationships that I need. Okay, so the law of cosines works when you have side angle side or side side side. It does work when you have angle side side, but it's so complicated that I recommend not using it unless, and who knows what Cynthia's going to do. She might throw one of those at us and we'll have to figure it out. Okay. And in the book, A is opposite alpha, right? B is opposite beta. And C is opposite, I think is that gamma? I think that's gamma. Alpha, beta, gamma. That makes sense. Okay. Now, in the book, that's how they're going to do that. I don't know why Cynthia chose that. I've never seen it before. That's just how she is. Okay. Turn to page 499, and let's do problem number 2. Little a is 6, little b is 10, and gamma is 100. I'm going to go ahead and call this, what would you call that? Oh, did I? Oh, I looked at 2 different problems. I'm sorry. 80. Instead of gamma, let's write C. Big C. It's an angle. Yeah. Right? 80 degrees, so it has to be an angle. Well, it's just a Greek letter, so we have X rays, we have alpha rays, we have gamma rays. It's just a name, like pi. Why do we call it pi? Because. So this is A, B, C, and then I know little a is 6 and little b is 10, and then this is 80. So in this case, I'm looking at side angle side. Now, which of the 3 formulas do I want to choose? Do I want the a squared formula, the b squared formula, or the c squared? How do you know c squared? The angle chooses it for you. Right? Every formula only has one angle. And the angle chooses the formula. It's either the angle you have or the angle you want. But the formula is decided by the angle. So in this one, we have to choose the c squared formula because I know c. So I'm going to write out the formula is c squared equals a squared plus b squared minus 2ab times the cosine of angle C. So c squared is equal to 36 plus 100 minus 2 times 6 would be 12 times 10 is 120 times the cosine of 80. So the cosine of 80, not 60, 80, is 0.17. And I'd probably use more decimals than that. Well, I would use more. I would probably use 4. Trigonometry can be kind of temperamental, kind of like logarithms. So I'm just going to put all of this together and then take the square root, right? So 136 minus 120, and I'm just going to do second answer to be a little bit more accurate. What do I do with that? Square root. Do I need plus or minus? Is the answer plus or minus 10.7? No, because the negative doesn't make any sense. So side C is 10.7. Okay? Do you need to see another side angle side? Those are pretty easy, right? Okay. Do you see a side problem in there? So let's do 12. Okay. So number 12, A is 6, B is 9, and C is 12. And oh, you're supposed to solve the triangle. Sorry, we'll solve this one. The last one, I should have finished, but I didn't. Okay. This would be B, C, and A. What angle do I want to find? Any one of them. I need to find one, so it doesn't matter which one I pick. Let's pick B. If I choose angle B, which formula do I use? B squared equals A squared plus C squared minus 2AC times the cosine of B. Yeah, if there's not a formula sheet on the test, let me know. That was my fault. I'm sorry. Yeah, that was bad. Okay. You're going to memorize this pretty quickly. Well, I mean, once you know one of them, you know all three, but I'll give you the formula. So, I'm going to plug everything in. 81 is equal to 36 plus 144 minus 2 times 6 is 12 times 2 is 144 cosine of B. Does everybody get that? 2 times 6 is 12 times 12 is 144. So I need to move all of this stuff over. So we'll take 81 and we'll subtract 36. Right. Yep. So, well, I subtract 36, and then I subtract 144. So subtract 144. And now what do I do with the negative 144? Divide. So divide by negative 144. So that one is a division. That's a good eye. So I subtract 36, I subtract 144, and then I divide by negative 144. Okay? Which has to happen. How do I know that 0.68 is a good number? It's less than 1. Now I do the inverse. So cosine inverse of the answer, and I get angle B is 46.5 degrees. Okay? Now what? Do the same thing for A, but the law of cosines is harder than the law of sines. The law of cosines is much longer and takes more effort. But now I could do A's and B's. So the sine of 46.5 over 9 is equal to the sine of A over 6. You only ever need to do the law of cosines once. And from there, you can do the law of sines. So in this case, I'm just going to multiply by 6. and I get 6 sine of 46.5 over 9. So 6 sine of the answer divided by 9. Why is that number good? Less than 1. Now what do? Invert the sign, and I get this angle is 28.9. Right, now I subtract them both from 180. So 180 minus the answer minus 46.56. And I get that third angle is going to be 104.5. Does that make sense? Okay, now let's see. Do they do angle side side? I sure hope not, because it's hard. Okay, it doesn't look like it. Thank you, Cynthia. Let me go back to that previous problem we solved. So in this problem, I found C to be 10.7. What would I do from there? Right. Now I can do the law of sines, and I have both C's, and then I could solve for B. Do you need to see that? Okay, and then once we figure out what angle B is, then you just subtract from 180 to find angle A. Easy enough? Okay. Now the law of cosines does one more thing for us. So your problem set from 1 to 27 just says solve the triangle. So you draw out the triangle, you use the law of cosines once, and then you use the law of sines to finish. And then in the next set, 29 through 49, you're going to find the area of a triangle. So go back to 496. Well, I guess you need to go back further to see the formula. So on 495, you see the area of a triangle formula. If you have side angle side, the area of a triangle, so the area, let's put area, is 1/2 BC times the sine of angle A. Now, don't look at your book. What would the other formula look like? 1/2 AC sine of angle B. And the third formula? 1/2 AB sine of angle C. Now that only works when you have side angle side. Okay? Really? For any triangle where the lengths of the three sides are known, the area for that triangle is given by that formula. Wow. I'm not sure why they want to do that. We'll look at that in a different way here in a second. So number 30, back on 499. Number 30 says B equals 6, C equals 4 times the square root of 3, and angle A is 30 degrees. Which formula do I choose? The one with angle A. So once again, the angle chooses the area, or the angle chooses the formula for us. So the area of this triangle is simply 1/2 times 6 times 4 times the square root of 3 times the sine of 30 degrees. What is the sine of 30 degrees? So our first triangle in quadrant 1, what's the height? It's either 1/2 or √3/2. Is the height the long side or the short side? It's the short side, so it's 1/2. So this turns into 1/2. So I get 1/2 times 6 times 4 root 3 times 1/2. This 4 cancels both 1/2s, and I'm left with 6 root 3. That's the area of the triangle. Okay, so 32. 32 is going to be, oh, that was cruel. Really? What's wrong with 32? We're not looking at the right sides. So number 32, B is 2 root 2, and angle B is 45. And then C is 4. Oh, man. Why did they do this? Okay, well, I guess we'll do it. So, what do we need to do? We need to find side A. Okay, but we have angle side side. So if we have angle side side, we want to use the law of sines. You can use the law of cosines, but you end up with a quadratic that you have to factor. Actually, that might be better. Let me show you how it works and see if you like it or not. Okay, so the law of cosines. Which formula do I choose for the law of cosines? The B formula. B squared equals A squared plus B squared minus 2, C squared, plus C squared minus 2AC times the cosine of B. All right, let's figure that out. So what is 2 root 2 squared? 4 times 2. 2 squared is 4. Root 2 squared is 2. 4 times 2 is 8. So 8 is equal to A squared plus 16 minus 2 times A times 4 is 8A. And what is the cosine of 45 degrees? No, root 2 over 2. So the square root of 2 over 2. Okay. So what should we do? Well, I have A squared and A, which means it's a quadratic. So let's move everything to the right. A squared minus this times this, that would be 4, and that cancels. 4 root 2A, and then I subtract the 8, plus 8 equals 0. There's already 16 on the right side. So Nate's going to plug that into his calculator. What do you get, Nate? Is that really a perfect square? Cut that in half. It is. Wow. That's really weird. So, without solving this, let me show you what happens. Let's say I solve this, Brent, and I get 3 and negative 1. What does that mean? Nope, that there's only one triangle. -1 cannot be the side of that triangle. So if you do the quadratic formula and you find out that one's positive and one's negative, then you only get one triangle. Okay? What if they're both negative? There's no triangle. What if they're both positive? There are two triangles. Well, in this case, we ended up getting two of the same answer, which is a 90-degree angle. So this is a right triangle. Yeah, we got tricked. It ends up being, I think it's 2 root 2, isn't it? 2 point. So the answer is 2.82. So that number goes right here, 2.82. Yes. A and B are the same side. Yeah. That was a really cruel problem. And then you could plug it into that. All right. So let's see if they do that again. 29 is fine. 31. Okay, are we doing 29? So every other one. 159, 13, 17, 21, 25. We will do 29, good. That one's okay. 31 is bad. 33, right. 33 is good, right? Looks good, yeah. A, B, and C. And then 37. 37's okay. 41. Okay. So now we need to look at the sides. Up until 41 we're okay. What if they give us three sides? So A, B, and C. Yep. So I'm going to do number 42. Look at 42. 42 says 9, 40, and 41. And I want the area. Okay? In order to find the area, I need to know one of the angles. Which angle do I need? Any one of them. Now, Cynthia gives a formula on page 497, which creates this value called S. And S is simply A plus B plus C over 2, and then you plug S into the square root formula. I would never do that. I would use the law of cosines to find an angle, and then just do the area formula. Does it matter what angle we solve for? Nope. So let's do this A squared formula. So 9 squared equals 40 squared plus 41 squared minus 2 times 40 times 41 times the cosine of A. So I'm going to subtract 40 squared, I'm going to subtract 41 squared, and then I'm going to divide by whatever that is. So 81 minus 40 squared minus 41 squared. Now what? Divide by -2 times 40 times 41, and you have to put those in parentheses if you do it this way. And I should get an answer less than 1, which I did. Now I invert the cosine of the answer, and I get 12.6 degrees. Oh, we did A. You're right. Okay. Now what do I do? Nope. We're looking for the area. So the area formula is, we use the A, so 1/2 times BC sine of A. So 1/2 times 41 times 40 times the sine of the answer. The area of this triangle is 180 square units. Okay. You handle that? So every other odd, we better look at. So 41 was fine. And then we skip 43. 45 is okay. Skip 47. 49, you can handle 49. Okay, and then you have some story problems to do. All right. Good luck.